Hello friends, today we will going to discuss about the unit number 3rd, that is the random process. And in the random process, this is the very important steps, very important point in digital communication. In this digital communication, there is a random process is a start from basics, that is the probability. All of you know that the probability theory in 12th standard, but now in the digital communication, again once more we have seen whatever the fundamental of the random process, that part we have studied here. The Fourier transform is the mathematical tool for the representation of the deterministic signal. And what is the deterministic signal? Its meaning of that we have able to determine or to predict the value of the signal, and that deterministic signal is the basically the class of the signal that may be molded as the completely specified the function of the time, and that a single signal is the random. What is the meaning of the random? If it is not possible to predict the precise value of the advance. And suppose there is a we have taken one example for the random. What is the meaning of the random? Random is a nothing but if you have to be if tossing a coin, and after tossing a coin we doesn't know in advance either it will be show for head or tail, okay, and that type of the signal we have called it is the random. Hence the signal is the random if it is not possible to predict its precise value in advance. Then what is the random process? The random process is the consist of a family or ensemble of the sample function. Means it is the set of the signals which is called as the random process, which acting as the random and which varies randomly with the time. Then random variable, basically the random variable, and in case of the random variable is obtained by observing a random process. Random process consists the ensemble of sample function which varies randomly with the time, and random variable is obtained by observing the random process at a fixed instant of the time. Means at a fixed instant of the time it will be given the output which is called as the random variable. Then probability. Then what is the meaning of the probability? Basically probability theory is the basic foundation of the random process or random variable, random functions, etc. The random theory is the rooted as the phenomena that explicitly or implicitly that can be molded by the experiment with an outcome that is subject to chance. Means probability theory is the rooted the phenomena that explicitly or implicitly is nothing but it is the output which is exactly opposite from the same system, and the experiment that can be outcome that's subject to chance. Suppose the experiment that will be observation of the result of the tossing a fair coin, and in case of the fair coin in this experiment the possible outcome of the trial of the heads or tails. Suppose in this while we have seen the probability, then here number of the experiment, means if an number of the experiment has the k possible outcomes, this you have to be do the experiment, and that experiment we have to be taken for consideration, its value is k for the possible outcomes. Then for that possible outcomes, for the kth possible outcome we have to be point which is called as the sample point. In collection of the sample point we have called it is the sample space. Means suppose we can denote the sample point, it will be denoted by sk having the k value, and that k value should be varying from 1, 2, 3 up to the k with the basic frameworks. And from that basic framework we made the following definitions. First is the set of all possible outcomes of the experiment is called the sample space. Means the set of all possible outcomes of the experiment we called it is the sample space, and that sample space is denoted by the letter S. Then an event corresponding to either a single sample point or set of the sample point in the space S. Then a single elementary, here is the single elementary sample point is called as the elementary event, and that entire sample space S is called as the sure event. or the null set or impossible event, and that null set is represented by phi. Here null set is represented by phi. Then two events are mutually exclusive. Then which two event we called? The two events are mutually exclusive if the occurrence of the one event is preclude the occurrence of the other event. Means suppose we have taken here one example. In that example, examination is the part of the curriculum. Okay, examination is the one part of the curriculum. Means curriculum is the main event. Okay, examination is the sub part. That's why examination is the main event which is to be occurred. Curriculum is the main event and examination is the sub event, and both are mutually exclusive to each other. Unless and until you cannot give the examination, your curriculum cannot able to complete it. The same way, there are the two events are mutually exclusive if the occurrence of the one event is precludes the occurrence of the other event. Then probability measure. Basically the probability is represented by the letter P, and it is the function that assigns on the non-negative number of an event A. Then non-negative number of an event A in the sample space S, and which satisfy the following properties. Then what are the different properties? That properties is given. There is a probability of A should be greater than 0 but less than 1. Means it is bounded between 0 to 1. This is the condition. It is the probability between 0 to 1. Then probability of whole sample. That probability of whole sample which is equal to 1. And if A and B are two mutually exclusive event, means A and B both are the mutually exclusive event, then how to write now that equation in the same way? The probability here, the probability P of A union B here, probability P is the A union B, which is equal to probability of A plus probability of B. Means if the A and B are the two independently event, and if it is mutually exclusive, then we write now the equation for its individual. It is the combination of the individual event. There is a probability P of A plus probability P of B. Okay, means P of A plus P of B is the equation. The next equation there is a 7.5. Then here is the sample space. In case of the sample space, there are the n number of the sample space is given, starting from S1, S2, S3, S4 up to the Sk of the sample space, and its individual event should be given. That event is A, B, C in this way. Okay. Then in case of the probability, here that probability is two value, either 0 and 1, and this is the sample space. In that sample space, number of the events should be happen. Then from the following properties, there are some properties of the probability, and that can be measured by the P by derived from the above axioms. There is the probability of complement of an event A, which is equal to 1 minus P of A. This is the first property. Second property is that when the event A and B are not mutually exclusive, means if the event A and B are not mutually exclusive, then how to write now the equation? P A union B, or A is mutually exclusive B, which is equal to P of A plus P of B minus A is not mutually exclusive B. And if P of A is not mutually exclusive B, which is equal to here P of A plus P of B minus P of A union B, means basically here come to the 0. Then third property is that if number of the event A1, A2, A3 up to the A of M are mutually exclusive event, and that includes all the possible outcomes of the random experiment. and basically that once we have to be combine the probability of probability or possible outcomes of the random experiment, which is equal to 1. Means here the probability P of A plus A1 plus probability P of A2 plus P of A of M event. Means here the probability of an event A starting from 1, 2, 3, 4 up to the M, which is equal to 1. Then next, let the probability P of B of A, means here is the main event, and in that event there is a B is the sub event. Here is the conditional probability, here is the condition should be put. Let P of B upon A, which denotes the probability of an event B given that event A has occurred. Then the probability P of B upon A is called as the conditional probability of B given A. Then here is to be defined, there is a relationship between the marginal probability, conditional probability and individual probability we have right now here. Then P of B upon A is defined as there is P of A is not mutually exclusive B, marginal probability, and P upon A. This equation should be given. And from that equation there is a Bayes rule is told. From that equation there is a if P of A is mutually exclusive B, means here is the marginal probability, there is a P of A is a mutually exclusive B, which is equal to P of B upon A into P upon A. If we write now here, if A is a not mutually exclusive of B, then same way we have right now here P of A upon B of P of B. Means that equation, the equation number 5.9, that will be put into the equation number 5.7. Then this same equation we rewrite here, P of B upon A, which is equal to P of A upon B into P of B upon P of A. This is the equation number 5.10. Then conditional probability. In case of the conditional probability, suppose that there is a conditional probability P of B upon A is simply equal to the elementary probability occurrence of an event B. Then how to write now? If the P of B upon A and P of B of these both events should be happened, then this is the marginal probability. In case of the marginal probability, this value is P of A upon B, which is equal to P of A into P of B. And once it is the union, P of A plus P of B. Then P of A union B, which is equal to P of A into P of B. And this value we have substitute in the previous equation, this equation. Then how to write this equation? P of A upon B, which is equal to P of A union not exclusive B upon P of B, which is equal to P of A into P of B upon P of B. Then P of B and P of B gets cancelled, therefore P of A, means P of A upon B, which is equal to P of A. Then from that equation we have called it is, from that condition, this case it shows that the A and B, these two events, they satisfy these conditions, and hence it is said to be statistically independent, which is called as the statistically independent. Of these two events are statistically independent. Then we move towards the binary symmetric channel. In case of the binary symmetric channel, here this channel is said to be discrete, and that is designed to handle discrete message. Then what is the meaning of the discrete? The discrete is nothing but it is the digital signal, and that digital signal having there are only two values. There is a logic 0 and a logic 1. Then this channel is basically memoryless in the sense that is the channel output at any time it depends on the channel input, that time only, means it depends only the present input and present output. because your output is does not depends upon the input, hence it is the memoryless. Then this channel is the symmetric. This channel is a symmetric, which means that the probability receiving symbol 1 when 0 is sent, and is the same as the probability of receiving symbol 0 when symbol 1 is sent. Okay, then we have right now here B of B0 upon A0, here B0 upon A0 and B1 upon A1, and that part we have to be substitute here. See, a priori probability. Then what is the meaning of the priori probability? See here, a priori probability of sending binary symbols 0 and 1. We are continue for the binary symmetric channel. Means a priori probability of sending the binary symbol 0 and 1. Then from here P of A0 which is equal to P0 and P of A1 which is equal to P1 is from this figure P of A0 and P of A1. Then P of A0 which is equal to P0 is P of A0, this P of A0 which is equal to probability P of 0 and probability P of A1 which is equal to P1. Hence these two are the priori probability should be given. Then conditional probabilities of error. Then what happens the conditional probability of error? The probability P of B1 upon A0 which is equal to the probability of B0 upon A1 which is equal to P. Means the conditional probability of error here P of B0 upon A1 which is equal to P and P of B1 upon A0 which is equal to also P, and these are the conditional probability error. Basically the probability P of B0 upon A1, then you see this channel having the name is P, hence the probability P of B0 upon A1 which is equal to P. Then probability P of B1 upon A0 which is equal to also P, and this is called as the probability error. Then the probability of receiving the symbol 0. Once the probability P is the receiving the symbol 0, then what happens? See, then probability P of B0, then we move again here. The probability P and probability P of if it will be receive the symbol 0 and if it will be receive the symbol 1, then what we do? The probability P of B0 which is equal to probability P of B0 upon A0 into P of A0 plus probability P of B0 upon A1 into probability of A1. Then we have observed the previous equation. The probability P of B0 upon A0, probability of P of B0 upon A0, that will be given here P of B0 upon A0, that will be given 1 minus, and probability P of B1 upon A1 is also given the 1 minus P. Then same thing we have happen to apply here. P of B0 A0 into P of A0 plus P of B0 A1 of P of A1 which is equal to here 1 minus P, and P of A0 will be taken here. P of A0 it is P0 plus P1. Then same way the probability of receiving symbol 1 is given by P of B1 which is equal to P of B1 upon A0 into P of A0 plus P of B1 A1 into P of A1 which is equal to P of P0 plus 1 minus P into P1. In this way we have right now the equation for P of B0 and P of B1 is the output of the symmetric channel, binary symmetric channel. Then from the binary symmetric channel, the posteriori probability we have to be find out. The posteriori probability, there is a P of A0 upon B0. B0 is the basically output and A0 is the input, but we have take the opposite ratio which is called as the posteriori. Then P of A0 B0 and P of A1 B1 we write now according to the Bayes rule. P of A0 B0 which is equal to P of B0 A0 into P of A0 upon P of B0, and P of B0 A0 which is given by 1 minus P, and P of A0 is given by P0, and P of B0 from that equation, P of B0 which is equal to 1 minus P P0 plus P P1. That value will be substituted here. P of B0 is 1 minus P into P0 plus PP1. Similarly, for the second channel, P of A1 B1 which is equal to P of B1 A1 into P of A1 upon P of B1 which is equal to 1 minus P into P1 upon P P0 plus 1 minus P into P1. Okay, which is called as the posteriori probability. I hope that all of you understand what is the meaning of the probability, which are the basic rules, which is called as the random experiment, sample space, Bayes rule, then relationship between the conditional probability, joint probability, then marginal probability, then here is the binary symmetric channel, how to find out its posteriori probability. That part you have seen in this video. If any doubts, any query, please write on my comment page. Please subscribe my channel, subscribe my YouTube channel, press the bell icon, never miss any updates. Thank you. Have a nice day.